So we talked about polar bonds. Now we're going to define bond type based on electronegativity. So the greater the difference in electronegativity, the more polar a bond is. If the difference in electronegativity is small, it's considered nonpolar covalent. So if we have electronegativity difference of less than 0.5, it is considered nonpolar covalent. The most common bond in this class, CH. The more carbon-hydrogen bonds a molecule has, the more nonpolar it is. Okay, so you could have 20 carbon to hydrogen bonds and one bond to oxygen, and then you have to decide, okay, am I polar or nonpolar? Well, what are you mostly made up of? Nonpolar bonds or polar bonds? If you're mostly made up of carbon to hydrogen bonds, then I'd say that you are nonpolar. Okay, polar covalent bonds. This requires an electronegativity difference of 0.5 to 1.9. So I usually say 2. So 0.5 to 2, then is your electronegativity difference, then you are a polar covalent bond. On the previous page, we showed that hydrogen to chlorine has an electronegativity difference of 0.94. It is a polar covalent bond. In this course, we are primarily going to be dealing with covalent bonds, breaking and forming covalent bonds. If we have an electronegativity difference greater than 2, then this is an ionic bond. You study ionic molecules in inorganic chemistry and Gen Chem, and we're not really going to have to deal a lot with ions in this class. Well, I guess we do use fluoride an awful lot, but that's because that's because HCl and HBr, we don't use fluoride. We use chloride and bromide a lot as ions, and that's simply because usually they're not in acid form. Remember, HBr, strong acid, hydrogen dissociates, so you get the ion. I'm devolving. Let's move on. Dipole moment. What is the dipole moment? The dipole moment is the net electronegativity of an atom, and the dipole moment should point in the direction towards the most electronegative atom. So if you only have 2 atoms, then the dipole moment is exactly in line with the direction of the bond, and for a carbon to hydrogen bond, the dipole moment is 0.4. So you can define the polarity based on dipole moment. Nonpolar. So we can just write N or Y depending on whether it's polar or nonpolar. So no, yes, 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 no, no, yeah, no, yes, barely, yes, 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 yes. So we've defined whether the bonds are polar or nonpolar based on the dipole moment. The dipole moment for 2 atoms is the difference in electronegativity. If you have more than 2 atoms, then it can get complicated, and you have to do vector math. Anybody want to go back to algebra? No. Okay, let's skip that then. Yes. Electrostatic potential maps. This is something that you're going to see a lot in our text. This is a space-filling model of atoms, which is color-coded to show where positive and negative charge is. Blue, cold, is positive. Red, hot, is negative. So, negative, positive. The more negative atom on the electrostatic potential map will be more red. The more positive atom will be more blue. One of the things that you should have learned in Gen Chem are the redox numbers of the different atoms. When hydrogen is bonded to a non-metal, it has an oxidation number of +1. When hydrogen is bonded to a metal, it has an oxidation number of -1. And so when we're bonded to a metal, hydrogen is more electronegative than a metal. It's going to be the negative atom in the dipole, partially negative. And when hydrogen is bonded to a non-metal, it's going to be the positive atom in the dipole and partially positive. When there is no dipole moment, you're going to have a neutral color. You should be very familiar with and capable of drawing Lewis structures in this course. There are several different ways to draw Lewis structures, and our preferred method is going to be skeletal structures. So you need to remember how to draw Lewis structures and to become very, very proficient at drawing Lewis structures. When you draw a true Lewis structure, you should show all bonds, all lone pairs, and all formal charges. What is formal charge? Formal charge is equal to the number of valence electrons minus the number of dots minus the number of bonds. So for example, if we have water, which has 2 bonds and 2 lone pairs, and oxygen has a valence of 6 electrons. We have 6 electrons minus 4 dots minus 2 bonds is equal to 0. The formal charge of the oxygen is 0, so we don't have to write any numbers next to it. Carbon forms 4 bonds in a Lewis structure. Do we need to go back over how to draw Lewis structures? Now you should be able to draw Lewis structures, right? We'll get there. We have instructions on how to draw Lewis structures later. I guess I could move it. I don't really want to. Carbon forms 4 bonds. Like I said, 4 valence electrons. It needs 4 more to get an octet, so those 4 more come from bonds. Methane is the simplest molecule of our carbon molecules. It forms 4 bonds to hydrogen. If carbon does not form 4 bonds, it is going to have a charge. So if carbon only has 3 bonds, then it should have a positive charge. And if carbon has 3 bonds and a lone pair, it should have a negative charge. We're also going to have to do radicals. That's going to be in chapter 11. No, 12. Chapter 12 is radical chemistry. And then right now we're going to focus on chapter 3 is going to be heavily dealing with drawing these carbon molecules, our hydrocarbon molecules. Carbon molecules contain carbon and hydrogen only. Okay, so when you draw a structure, you have to, from the information that you're given, be able to create a valid Lewis structure. Nitrogen prefers to form 3 bonds, 5 valence electrons plus 3 bonds gives it an octet. It will have 1 lone pair, and if nitrogen differs from this 3 bonds and 1 lone pair, then it should have a charge. It can't exceed 4 bonds. That's impossible. It's in row 2. If you're in row 2, you can't go beyond 4 bonds. So maximum number of bonds is 4, but if it has 4 bonds, then it's going to have a positive charge. If nitrogen has less than 3 bonds, then it's going to have a negative charge, and you need to be able to figure that out. Okay, so given the Lewis structure, can you tell me the formal charge? You should be able to, because you can count and you can see that Lewis structure. You can say, look at your periodic table. Okay, it has 5 valence electrons, minus the number of dots. Okay, 4 dots, minus the number of bonds, 2 bonds. What's 5 minus 6? -1. There you go. We got our formal charge. Okay? Oxygen prefers to form 2 bonds, has 6 valence electrons, needs 2 more to make an octet. Those come from bonds. So we're going to have 2 bonds and 2 lone pairs. And then if it differs from 2 bonds and 2 lone pairs, it will have a charge, and you need to be able to determine what that charge is. Hydrogen and the halogens all form 1 bond. So if we have Br2Cl2, there'll be 1 bond between halogens. If we have HCl, HBr, HF, HI, then we are going to have 1 bond from hydrogen to the halogen. So, and a halogen, it can only form 1 bond. It's in group 7, so it has 7 valence electrons. It needs 1 more to get an octet, and that 1 more comes from the bond that it makes. So then it has an octet. So 1 bond means that it's going to have 6 dots when it's neutral. So we can do that like this: 7 valence electrons minus 6 dots minus 1 bond equals 0. So that's what it takes to have no formal charge, 3 lone pairs, and 1 bond. If we differ from this, then we will have a charge. Hydrogen does not form, if hydrogen does not form a bond, then it will be an ion. It cannot form more than 1 bond. It can only form less than 1 bond. So when it forms less than 1 bond, it will be either an ion or a radical. The number of bonds plus the number of lone pairs equals to 4. And 4 times 2 gives us an octet of 8. This slide will help you with item 6 of the homework. So that's what these item numbers are. This is referring to homework number.